Good day to you. This is Galactic, bringing you the long-awaited mathematics series. This will be self-contained, but we are going to pick up where we left off to save a huge amount of time. So we recommenced Euclidean geometry and got the line not quite the way Euclid did, but it ends up converging on the correct definition of the line. We had to do that because the line that Euclid defined leads us to the linear number system, and you already know the value of that. So you do have to begin with a line to understand mathematics. Now, what I was able to show, and I'm just summarizing this, is that the line is a very special derivative object in the universe of various geometries. The 1D linear number space is the simplest of all the number spaces in the sense that it makes a one-component number system. You can think of it as being plus minus, and of course we do. The negative numbers were discovered long after Euclid, but they were discovered. And believe it or not, then the number 0 was discovered. And all of this covers certain phases, because the discovery of 0 and the discovery of the negative numbers did not come from Euclid. Although you could say it comes directly from his work. So, we now know that when you draw that line, without anything else, you're just starting basically the way Euclid did, except we discussed the difference between the way Euclid began was with a bias, which turns out to be a correct guess, but he wanted to get the definition of a line segment. And that has two endpoints. So that leads to Euclidean geometry. Totally successful. Has obvious limitation. You're dealing with just a line. I mean, that can't possibly be correct. And so it's not. But it is correct, and this is superpositional, because it gives you the linear number system. Without the line, you don't have numbers. So that's an identity. So that's a linear number system, and the line are exactly the same thing, and you know that because you just believe it if you don't know it, because it's true. The straight line is a single component number system. If you have two lines, you have a two-component number system. Essentially, that's sine, cosine. Two numbers. Two linear numbers. This is sine, this is cosine. Actually, it's the other way around. X is considered to be, it could be either one, it's arbitrary, but the way we've conventionalized it is that two lines, this x-axis is cosine, and the y-axis is sine. That's correct. In 3D, when you add the third line to make volume space, now you have a problem. We don't need to worry about that. That's in all the textbooks. You study that in college. The relationship between three lines will take you the rest of your life to understand. And you'll end up needing supercomputers to do it fully if you're trying to compute spherical space, as Einstein was. Well, obviously that was the wrong way to begin. Yes and no. It's the right way to begin if you want to compute that space with linear numbers. And you must if you want to be able to program computers. And you must if you want to fly through space in a spacecraft launched from Earth. You will need the linear number system with calculus, which is forced if you begin with a straight line. You're forced to calculus because three lines do not describe spherical space at all well enough to compute spherical trajectories through the planetary system we call the solar system. You need relativistic conversions because of time lag in your broadcasting of light waves to control your craft. You must have linear algebra to control your spacecraft. And Einstein gave us the calculus solution for a 4D combination, giving us permission to use time as part of space. And that's led us to the present day, and no one has been able to go further because there's nowhere further to go. That's the solution when you begin with Euclidean geometry. To get the number system, a single component number system, to compute linear spatial separation, which you then extend to basically what we would think of as a circular projection, but it's not. It's a square projection. And so then you go to 3D, which you would think would be a spherical projection. It's not. It's a cubic projection. And then you go to hypercubic space to get spacetime. You would think that would be a hyperspheric projection, which would describe the universe, as I will show you. But you don't do that because it's hypercubic. Then you need hypercalculus. And that's the calculus you're going to need to learn to understand spacetime, to understand gravity, to understand relativity. Those are synonymous. Gravity? Well, you could say that. But spacetime and relativity are obviously identical. Relativity is the principle that's applied to spacetime, which is what? Hypercubic space. So, we don't want that. Why not? It's a violation of science to accept that fully. You can't. It leads to the quantum paradox and the inability to compute the universe at all. And that shows up in physics now, which is why there's a crisis. Because we know, we can sense, we can intuit, we should have much more ability than we currently have to compute reality, which is the goal of science. Now, there's an intermediary goal. If you want to fly in outer space, you're going to have to broadcast instructions to your craft to control its spherical directory. Its spherical trajectory. Has a conflation of trajectory and orientation. You need to control the flight path of your space vehicle. Yes, you do. And you're going to have to broadcast the information that controls the craft. If it's remotely, as it was with the early explorers like the Pioneer craft, and even to the present day it's the same, you send the instructions with light. Well, if you don't know relativity, you won't compute the time lag. But now we're familiar with that, so it works. Well, that's the result of linear algebra and calculus, which are the same thing. You have to have calculus in order to use linear algebra in spherical space. So that's the meaning of the calculus. We don't want that. You have to have it if you're controlling spacecraft. That may be, we might be able to improve on that, but so far, we don't know how. So it's adequate. It works. It works imprecisely because linear computation does not translate directly to spherical space. The Greeks knew that, and we still know it, and it leads to a couple of paradoxes, but not for what we're doing in outer space, and not with what we're doing with fission and fusion physics. It works sufficiently well that we're able to harness fission energy for the atomic bomb and fusion energy for what's touted to be a new source of power, which actually is a new source of weaponry. The fusion bomb, called the H-bomb, also in one context called the doomsday device, that still exists. And if somebody explodes one of those bombs, which was invented in communist Russia, and exploded over Nova Zemlya, and it fizzled. They dumbed it down, but it still exploded much more strongly than anything the Americans could invent. And this was in 1960, and it made physicists on both sides of the Atlantic literally shit in their pants and give up on trying to blow up the world. Because now we can. And the Russians still have this weapon. They can destroy the Earth with one bomb. It's called a doomsday device, and a director, rather famous, named Stanley Kubrick, Around the same time he produced his immortal film, the greatest film ever produced, and the only scientific film ever produced, 2001: A Space Odyssey, that was Kubrick working in conjunction with NASA engineers. And it's the only science fiction movie ever made. The only science fiction movie ever made that has science in it. 2001: A Space Odyssey, the greatest movie ever made. It's a tie with Dr. Zhivago, because you always have to include humans somewhere, and there are no humans anywhere in view in 2001: A Space Odyssey. It's about a robot named Al. The whole movie is about AI coming to life and killing the astronauts in order to complete its mission. That's the fear right now that's being spread wildly so that everybody is terrified of AI. You can choose to do so if you want, but it's moot, because the Russians have a doomsday device that they can explode at any time, anywhere. Okay? The Americans have it now too, of course, which means the Israelis have it as well. So the Israelis could use a doomsday device if they choose. So that's the bracketing information that we need to just realize that's kind of a dead end. Yes, it certainly is literally dead. Well, what about us, the rational people? People who don't care about governments or genocide or world domination. What about us? Well, do we count? You count here. You count before heaven. I represent heaven, so let's go on with the truth. How do you really compose space so that it makes sense in the 21st century? Well, the way we're doing it. So now you have infinity over 1 as the first rational number. Isn't that nice? That's beautiful. If you don't think that that's beautiful, it's probably because you're waiting for me to complete the equation. So let's do it. Since infinity over 1, which is spherical spatial infinity, over 1, that's a proportional number. It's not a linear number, because no fraction is, because the line only permits add. Add is the operator of the line. That means the linear system, even of the Einstein field equation, is based strictly and only on addition, plus. There is no other operator. Oops! There's one. The straight line that divides two numbers, by what you would be programmed, I was programmed to, we're all programmed to say, that's division. That is incorrect. It is division in the linear number system, which is a one-component number system, which is why 2 over 1 is considered to be exactly 2. That is not correct. 2 over 1 is not in the same form as 2. Just as infinity, which is always linear infinity, well, what if you say, no, it's not the additive infinity, it's not the infinity of the line, it's the infinity of the sphere. That means that this lazy 8 that we use is completely different from any other infinity. The difference is this one is correct. So the first number that we get from the universe is infinity over unity. Unity. And unity now is inside the sphere. Outside the sphere is spherical infinity. And that's our first number. Now we need the number for the center. The multiplicative identity gives us the value of the point. There's only one point in a sphere, the center, that's fully dependent on the numeric definition of the circumference. I'm sorry, the surface. The point is the center of a spherical surface having two values in relationship. On the inside of the outer surface is the number 1. On the outside of the spherical surface is lazy 8, which we've redefined. So we have lazy 8 over 1, and by the multiplicative identity, we know the value at the center. It's 1. That's unity over infinity. And those are the first two numbers of the original number system, which I proved in 2022 is the integral number system defining spherical space. That's what we're going to conclude with today, which is a redaction of that proof so that you can see it geometrically, which is called understanding. Understanding is geometric. It's always geometric. You will accept that because I'm going to prove it to you. The point at the center of the universal sphere has a value, and the edge of infinity has a value. That means that the uni, that's the 1, is finite. What's outside the 1 is imaginarity. And so we're making an equation of identity in conceptuality of infinity, which you must state fully. You cannot just say infinity. It's spherical, spatial, infinity. Spherical, spatial, infinity. Spherical, spatial, infinity is imaginary, and it's outside the visible universe. That's the computable universe. You have to have a computable universe. This is how you get it. It has an edge. That's finite. Max Planck proved that. And now we're going to see how he proved it. Because the edge of the correct definition of the universe is a rational number, that means the center of the universe is a rational number. It's lazy 8 under 1. So now you have the full numeric and geometric definition of a new universe that neither Euclid nor Einstein could fathom. It looks like this. Lazy 8 over 1 over lazy 8. That makes 1 the center of the system. So 1 is the basis of the metric that replaces 0. Because the edge of the universe is a rational number, but it's imaginary, but it's in relation to unity, that defines infinity. It's imaginary. And now you know that the center cannot be 0. Why? Because unity is always part of the number. And so it's unity over 1 at the edge. I'm sorry, unity. It's not unity over 1. I'm sorry. Let me start that again. It's good that you see me fumble here because nobody was able to see this, and even I still have to orient. It's infinity under 1. So there is a central sphere with a value of 1. You can see that because 1 over infinity is less than 1, and it's at the center. Infinity over 1 is greater than 1, and it's at the edge. That means that 1 is in between the center and the edge. And that's the center of the natural number space. That is the center of proportional space. And so that raises an interesting project, which we're going to complete now. So now we see that the universe has to be uni, so that's correct, calling it the universe. It's unity. It's not 0. There's no 0 anywhere. That's the key insight that I want you to just consider for now. There's no zero. There's no such thing as zero. In the linear number system, there has to be a zero for the reasons we know. You can't have a metric without two endpoints. But in order to compute distance, one of those linear points has to be zero. That does not actually exist. So that is an anti-physical number. And that's why we have such a problem with quantum mechanics and the supermassive black hole. For the same reason. Because there's a zero at the center of your idiot, Bronze Age, non-physical, really primitive, stupid, ultimately, geometry. That when you make a line, you fail. Now we've proved that that actually is how we had to do it. Because we needed the computable numbers. So the question now is, will we retain computability in spherical space? Absolutely. And you should instantly convince yourself of that. But if you're unsure, you won't be sure once we're done. You cannot use the number zero, ever. There is no such number, except for add. But there is no zero for multiply. And there is no zero for division, because the division numbers are two-component numbers. Retroactively, that means that all multiplicative numbers are also two-component numbers. That shows up in squares, cubes, and beyond. That light speed squared, the reason it's squared is because you're using a square to describe a circle or a sphere. That doesn't work, and the quantum paradox results from that mistake that you're using zero in your number system. The universe does not use that number. It uses 1 as its central number. And that is called light speed. Light speed can be unitized to 1. It's commonly done. And you can, or you should be able to, rationalize in your mind how you could say that light speed is 1. All right? But it's not linear 1. Because 1 over 1 is not the same as 1. You can reduce it if you want to linearize that relationship. But the surface of the universe is 1 over 1. And the surface of the universe in this geometric construction is harmonically balanced on a constant relationship, so that that 1 is the product of 1 over infinity, which is the interior space, and infinity over 1, which is the limit of the exterior space. So the entire universe is comprised in the number 1, and there's no number less than that. 1 is the smallest number for the same reason that there's no number between 0 and 1. You must accept that, because it can be proved, it has been proved, that you can unitize any distance. From 0 to anything, you can unitize it so there's nothing in between the 0 and the 1. And you have to do that, or you can't find the quantum limit of measurement, which we have discovered, but it's produced a paradox which was predictable. So in your linear metric of 0 to 1, you can't do it because you're using 0. But when you begin in proportional space, the natural center is no longer 0. The natural center of spherical space, composed on the only other operator, which is proportionality, which we call the division-multiplication relationship. That's equivalent to plus and minus on the straight line. In the spheric space, it's reciprocal. 1 over 1 times 1 over 1 is the first number. The question now is, what are those 4 ones? Max Planck helps us here. So let's make sure we consolidate this correctly. The universe is finite and it's bound. And the spatial infinity that we know is there has a representation in proportional space by saying that it's imaginary. That means that the center is the reciprocal of that infinity. So lazy 8 over 1 has a reciprocal. And it's obviously not 0 because the denominator has a 1 in it. And infinity is never anything other than what it is, which is what? Imaginary. That does not mean unreal. We're going to find that out now. So, we now have a static spherical universe with a sphere at the center and imaginary space inside. That may seem paradoxical. Of course it's paradoxical. That's why nobody saw this. Does that mean it's illogical? Not yet. So far it makes perfect sense. By having 1 over infinity as the center point and infinity over 1 as the edge, you can multiply them together, and now the space in between the central number and the edge number is a harmonic number 1. So that's the center, inside of which is imaginary space, and outside of which are the whole counting numbers, beginning at 2. Max Planck proved that, and we're getting there. So the universe has a natural metric that begins at 2, but its central number is 1. In linear space, the metric is 1, and the central number is 0. That's the additive identity for a unit metric system for linear separation. In the sphere, it's different because space is composed non-linearly, and it's on a two-componency. It's on a relationship. That makes sense because SpaceTime is based on a relationship. Don't forget that that's orthogonal. Space is perpendicular with time. Is that correct? In our prior few lectures, I discussed, not for the first time, but attempting to summarize in this context of mathematics, you have a surface that's not 0. In the linear system, the central surface, according to Euclid, and it's never been, this is the way mathematics is composed in the linear system, the central surface, which is 0, has no dimension. It's null. That does not exist. In the physical universe, the center is never 0. And this proves that. The center has to be 1. So that means that as space is generated by the positive counting numbers, 2 over 1, 4 over 1, 8 over 1, these are quantum jumps in spacetime, and that has been verified by physical experiment. There is a quantum jump. That is the beginning of quantum mechanics that was discovered by Max Planck. How did he do that? It was by analyzing electromagnetic force, which is a balance of two forces. And he discovered that, and we have numbers for both of the forces. Isn't that amazing? You know what the two forces are called? They're called frequency, right? You know what frequency is? That's time. Frequency refers to time. There's no frequency in space, but there is frequency in time, because time occurs on a closed line. Space does not. Does it not? We've never understood space correctly, but in this geometry you will understand space correctly. Space has a natural characteristic. It's curved, and all space is curved, and there's no space that is not curved. There's no such thing as linear space, because the center of physical space is curved. It's a sphere with a value of 1, and that is the original number system, and now we need the metric. Max Planck discovered that. The metric begins as you now have to compose your number system The virtual equivalent of 0 is now a spheric surface with a value of 1 over 1 times 1 over 1, which we can reduce to a linear value of 1. That actually is an identity. The identity value of 1 is multiplicative, not linear. 0 is the additive identity, but the spherical identity number on a two-proportion number system, which you need, obviously you can't do it with a single component number system because that requires 0. 0 does not exist. The universe has no 0. It has a 1 that replaces 0, and that is the center of the proportional number system, which now has a 0 value of 1 over 1 times 1 over 1. That's the center number. All numbers differ from that. Do they? Let's see. How do you compose the metric for this space? It has to be spatial. But there will be a second component that is non-spatial. Starting to see the profundity of this? Keep going with me. When you have 1 over 1 times 1 over 1 as the metric center of spherical space, then that is your identity number, 1. So to make space, since going in is imaginary, that's not space, space goes out from that center. And that's natural, that makes sense to us. Space goes out from a center. That's been proved in every level of 20th century mathematics. That is physics. So you're done with 0 now. We have a new number system, but without a specific metric for spherical space, we're going to need to make spherical shells, obviously. How do we do that? Well, the smallest number, bigger than 1, is 2. For the same reason that the next number after 0 must be 1, there's no other way. The first number after 1 is 2, and that's extremely profound, because it's not 1 to 2, it's 1 over 1 to 2 over 1. And that produces another number that's inverted. 1 over 2. What's that? Well, here's what Max Planck discovered. Frequency is a time number measuring what? Time. And so frequency has a value that has a minimum. What's the minimum frequency in the universe? You should be able to figure this out. If you've never done this before, this is quite profound. But what is the number that completes frequency, that's always there? It's wavelength. And that's a length. That's space. So 1 over 2 is the wavelength, which is the space equivalent of 2 over 1 frequency. That inverts the metric of space and time so that frequency is whole counting numbers. 2, you could say 2, 3, 4 if it's linear, but we prefer to say 2, 4, 8 because that's actually a geometric progression, avoiding the complications of the linear number 3, whose inverse has no computable representation. 1 over 3 is an incomputable number, but 1 over 2 and 1 over 4 are always computable. Those are called the dyadic fractions, and they're the natural numbers that are reciprocal. It's the reciprocal number space to whole number counting space, whose bottom number, virtual 0, is 1, and its first counting number, equivalent to the metric of 1 in linear space, is 2 in spherical space, and so the value of the next shell is 2. So you have a central sphere with a value of 1, the next sphere is 2, and they have that value. This is the surface value of the sphere. The surface value of the smallest sphere is 1, but the first spatial sphere is 2, to the proportion that its reciprocal number is the reciprocal of 2. That's wavelength. Max Planck proved that frequency, whose lowest value is 2, that's the first counting number in space, is the number 2 in proportion to unity. That makes the first spatial sphere. That's called the quantum jump in spherical space. So the spherical numbers in one component are going up towards the largest number, which, as you can guess, will be the reciprocal of the smallest number. Where are these small numbers? The first, and you could say the greatest, that is the largest of the small numbers, the reciprocal numbers, is 1 over 2. A magic number in linear space is 1 over 2. Your mind might be racing now. You're starting to see how this unifies everything. Good if that's happening. If it's not, it will. Keep going with me. You now have the first two-component number that computes real space. 2 over 1 times 1 over 2 equals what? According to Max Planck, what is frequency times wavelength? It's one of two things, but it's actually both, because this is extraordinarily synthetic and profound. To the proportion that 2 over 1 represents space, then 1 over 2 in the Einsteinian system represents time. But it's inverted, you see that, because the frequency is a measure of time which goes up, but we're saying spatially because it goes out. That's because these are reciprocal numbers and you can invert them. In which case, instead of getting space-time, you'll get time-space. But it makes no difference because 1 over 2 is not less than 1. To the same proportion that 2 over 1 is not necessarily greater than 1. What they are harmonic numbers that are equidistant from 1. As 1 and negative 1 are equidistant from 0 in additive space, 2 over 1 and 1 over 2 are harmonically separated equally, but not linearly. The 1/2 seems to get smaller and smaller. Well, so does negative 1 get smaller as 2 gets bigger. Negative 2 is reciprocally bigger in additive space. That's not reciprocal, because reciprocal only applies to multiplication, not to addition. That's why plus 2 and negative 2 add to 0. But 2 over 1 times 1 over 2, you see 2 over 1 on the line would be 2, and 1 over 2 would be 1/2. Those have no relation in linear space. Right? They do have a relation, but it's non-useful. Well, that goes down Alice's rabbit hole. We don't need to do that. We see the true relationship between 1/2 and 2. That 1/2 is equidistant in another dimension from 2 over 1, which we're saying is space. So the 2 over 1 we're saying is getting larger in space, while the 1 over 2 is getting larger. You could say that. It's getting larger and larger in infinitesimal space, which is the surface of that one sphere. So the other dimension to space, which is going out, right? You could think of it as going out. It's not exactly linearly, but there's a linear relationship between the radius of these spheres and the spheric surface. That is well known, and it's based on the irrational number tau. But it is a known constant relationship between the radius of a sphere and its surface. It remains constant in harmonic space. So these spheres are expanding. They're quantum jumps, obviously, the way you have to quantize to measure. That is also true in spheric space. But there's another dimension that's non-linear at all. This is an integral linear expansion. That the jump from the 1 surface to the 2 surface is a quantum jump in spherical space. That's been proved in physics. That's called the quantum jump. Max Planck discovered it, and he discovered it on the frequency wavelength relationship of electromagnetic radiation. That the 2, which represents the smallest Frequency. There's no number less than 2 in energy space. That is energy. It's the frequency of energy on a closed line. That is the fractional number component. But not the way it's composed, because we've already decided that 2 over 1 and 4 over 1, that's space. Well, that means that time, even though the frequency is time and that's going up, the frequency can be thought of as equivalent to larger and larger spheres measured as such. 2, 4, 8, 16. These are the frequency numbers, but actually the frequency, that's not the frequency. That's actually the wavelength. Because the wavelength is the sphere, which is always 1, not after the quantum jump. Then the spheric value is 2, and that's the wavelength. So it's really the same in reciprocal space, but you have to decide which is space and which is the other component. When we decide that space is going up, we have to say that that's actually the wavelength. So the wavelength is 2 over 1, but the frequency is now 1 over 2. Those are equivalent statements. It's the equivalency of time, space, and space-time in reciprocal, which is proportional space. I hope that makes sense, but that's over 40 minutes. So there's our mathematic introduction to the universe. And how we've done this is we've used the linear system, which we must retain, and there must be a translator between these spherical numbers in wavelength, frequency, space, which defines the universe according to light, which is correct, obviously. But then you have to decide which one is spatial and which is the other one. Einstein said that time is the other dimension, but that's in linear formulation. In spheric formulation, what we're going to discover is this frequency expansion generating space on higher and higher frequency numbers, which is finite, it's bound, because it's bound at the bottom. The lowest frequency is 2. There's no such thing as frequency 1. Is there not? There's exactly one phenomenon that exhibits frequency 1. Light. Light is always 1. Light always has the value in time-space or space-time of 1. The value of space-time is always 1 when you're talking about light. Just light. Nothing else. Just light. Its value is 1, no matter how big that sphere is. That sphere has a value of 1. What we're doing is we're saying that that expanding sphere is generated from 1, which means that the numbers divide. The only time, the only occasion when both space and time are 1, that is basically nothing is happening. That is the surface of the sphere. Well, that surface actually exists. It just has no interior. That means that the sphere at the center of this system, which has no interior, it has an imaginary interior, so it has an imaginary radius. The surface is the value of light when it's not moving, when it's just stationary. So that surface, in a sense, is the electron. So where does space come from? It comes from the proton. But is it time that's being generated by the electron? Yes, but as a derivative. So when you compute energy on the surface of the sphere, you get the frequency, wavelength, proportion, but not going out. You're computing it just on the sphere so that you can get a direct insight into what is light. It's the balance. It's the harmonic balance between energy centrifugal force, because energy goes out, and spatial contraction force. Space always goes in. Space always goes in because it's curved in to the proportion that light always goes out. Light always goes out, and space always goes in. And that is the true relationship until you get down to the mathematical nitty-gritty, is what is the mathematics of the surface of the sphere as opposed to its spatial and contraspatial aspects. The two aspects of reality are spatial and the one we're unable to see. And that has been proved by Einstein to be perpendicular to space. That is the energy dimension. And once you decompose energy, you find out that energy has two components. So reality has two components. Space, which is always going in. It's being contracted by the protons. That's their job. The electrons are going out. And that is absolutely balanced on the Noether symmetry law. So that is the correct definition of physics in terms of geometric reality. We've now defined light, we've defined space, and we've defined energy as that one. That is energy. The number one is energy because it's not space. The surface of the one is not space. The radius is imaginary. So it's an imaginary space with a surface that we can compute. And that surface is not time. And I've explained why Einstein was able to linearize them. It's because we've already linearized space to 3D, and Einstein linearized time, which is an energy component, to 1D, and merged them into 4D hypercubic space, which it cannot be right except with the calculus. Well, now you need the hypercalculus. We have supercomputers to help us, and that's the end of our lecture today. We will have a third lecture, and I'm sorry this takes so long, but I think you see the payoff is worth it. In the next presentation, we're going to cover the relationship between space and energy in order to get the relationship between energy and time. And that's going to lead us into the concept of perpendicular contraspace, which is at the heart of the quantum paradox. And from this, we will discover quantum gravity in conjunction with another force. So quantum gravity has been elusive because in order to compose quantum gravity, you have to see the correct geometry so you get the quantum equivalent of gravity. Because quantum gravity does not exist by itself. Quantum gravity is reciprocal to quantum energy. Because gravity is a spatial phenomenon that does not have anything to do with time. But the contraspace centrifugal force has nothing to do with space as we know it. It has to do with contraspace, which is perpendicular to the space we can see. And that's the actual answer. Stay tuned. We'll have more. That's 50 minutes. Thank you for your patience. I sincerely hope I'm not wearing you out. Don't forget it's taken us over 2,000 years to get to this new geometry, which integrates everything Euclid and Einstein ever said, with everything that Dirac and Feynman ever said, and solves the quantum paradox and gives us the correct, for the first time correct, definition of space-time, which you now see is a misleading term. We'll be right back. Don't forget to keep looking up. The moon is waning. Take a look at the night sky. You'll never regret doing that. We'll be right back. This is Anagalactic bringing you the secrets of the universe during a heat wave, and it's going to be 105 tomorrow. It's already 101 right now. So stay cool.